Everyone, there are 10,000 ways to solve this type of problem, but today I insist on using the method of combining algebra and geometry. Let's see if you can understand the diagram I draw. Once I draw it, can you see the answer? The problem says, given that x plus y equals 5, find the minimum value of x plus the square root of x squared plus 4y squared. Everyone, let's try to combine numbers and shapes. Look at this area here. What does it make you think of? Isn't this related to the Pythagorean theorem? Isn't it just the square root of x squared plus open parenthesis 2y close parenthesis squared, right? The Pythagorean theorem involves drawing a right triangle. So shouldn't I draw a right triangle here? Let's suppose this side is y, then this side must be 2y. Let's say this is 2y and this is x. Then the hypotenuse, everyone, would be the square root of x squared plus open parenthesis 2y close parenthesis squared. All right, and what about this one? This is actually just x. In other words, what we're looking for now is the minimum value of the sum of this line and this line, right? Do you understand that it's about adding this line to this line? The minimum value of their sum, but we haven't used the condition x plus y equals 5 yet. Everyone, how do we use this condition? How do we use this condition? How do we combine it? Take a good look, everyone. Isn't there a 2y here? Let me suppose here I extend something. I'll extend twice x, 2x. If I connect this diagonal, doesn't it form a triangle? Isn't 2x plus 2y a fixed value? How long is it? What is it? The sum of the two is 5, so it's 10. You have to be careful when solving problems. Don't get so confused. Hey, do you understand this reasoning? So 2x plus 2y is always equal to 10. X and y are variables. That is, the length of x can change and the length of y can also change. This point is a moving point and can be assigned freely. What we're looking for is the minimum value of this line plus that line. Is this angle alpha fixed? In other words, if this point is here, everyone, hasn't x become this long now? Hasn't this diagonal moved over here? This becomes 2y and this becomes 2x. So this point moves. When is the sum of this line and that line minimized? That is to say, when the sum of this line and that line is minimized, can you understand this reasoning? This angle is fixed. Why is it fixed? Because the tangent of alpha is the ratio of the opposite side to the adjacent side, which is x to 2x or 1 to 2. Can you understand this reasoning? So when is the sum of these two lines minimized? When the sum of the two lines is minimized, doesn't it remind you of the general and the horse in chess? Can we create a mirror image? Yes, let's create a mirror image. Here, isn't this an alpha? Add another alpha to it, add another alpha angle. Draw a line, and then whose mirror image do we make? Whose mirror image are these two lines reflecting? This point is fixed. So of course we take the mirror image of the fixed point, right? Make a mirror image perpendicular to this line, perpendicular to this line. In other words, if this point is A and this is B, then the mirror image of B is here. So this line, doesn't that mean this line is always equal to this line? In other words, this point will also move, this point will also move, and this point will also move. So when is the sum of this line and this line the smallest? Isn't it when you drop straight down from this point that it's the smallest? So when the point is moved to this position, everyone, this line, meaning this line here, when they're equal, the sum of this line and this line is minimized. I got a bit confused there. In other words, this is x and this is 2x. Isn't this diagonal line it? So the minimum value of this line plus this line is just this. Now, how do we find this length? How do we find this length? This is a perpendicular line. How do we calculate it? What method can we use to make it clever? We can do it like this. Everyone, the tangent of this alpha is just the tangent value of this side, right? It's 1 to 2, meaning the opposite side to the adjacent side is 1 to 2. Now pay attention, is this side to this side also 1 to 2? Because this angle is fixed, the ratio of this side to this side is 1 to 2. Suppose this length is A, then this length, let's say it's A, so this length would be 2A, right? This length would be 2A. Now, isn't this length 10? Can we solve for A? Let's set up an equation. The square of 2A plus the square of A is 5A squared. Equals 10 squared, which is 100, right? So that means a squared equals 20. Then A is the square root of 20, isn't it? The square root of 20 is 2 times the square root of 5, right? So it's 2 times the square root of 5. Now, what about the total length? Isn't the base length 4 times the square root of 5? If this length is 10, then isn't this also 10? Isn't this also 10? Because that's the case. This is the altitude, and this is an isosceles triangle. This angle is equal to this angle, and these two large triangles are congruent, right? So what we need to find is this height, right? Let's denote the height of this triangle as h, okay? If we use h, then by equating the areas of the triangles, we can solve for this height h. So, multiplying the base by this base, is that equal to this base times its height? What is this base? 4 times the square root of 5, right? It's a bit messy. The drawing is a bit messy. Can everyone understand? Later, you can work it out yourselves. It's base times its height. What is its height? It's 2 times the square root of 5. Everyone, isn't that right? This is 2 times the square root of 5. So isn't this side 4 times the square root of 5? Because tan alpha is 1 to 2. Tan alpha. It's a 1 to 2 ratio, which means this side and this side have a 1 to 2 relationship. So it's 4 times the square root of 5. In other words, it's 4 times the square root of 5. So this length is also 4 times the square root of 5. Its base times its height equals its base times its height, which is 4 times the square root of 5 multiplied by 4 times the square root of 5. Right? Then what is the value of h? It's a bit messy. You can redraw it yourself later. For this base, what's its square? 4 times 4 is 16. 16 times 5 is 80. So 80h times 10 equals 8. So does 10h equal 8? Is this height 8? Ah, so the minimum is 8, right? Everyone, the diagram for this problem is a bit messy. Later, please redraw it carefully yourselves and check if what the teacher did is correct. Everyone.